All right, so this is part B of the 5.2 multiply. I did a lot of the multiply. Now I need to do the divide the radicals. So this is the part B video. Let's do some division of radicals, okay? So when I see here problem number 25 on division, we want to make sure that we multiply. We don't want radicals in the denominator. That's all it is. We don't know what this A is, okay? And if this A was 0, we have no clue what this A is. And if this A was 0, we would have 6 times 0. And 6 times 0 is 0. And then the square root of 0 would have been 0. And then 4 times 0 would have been 0. So we would end up with 0 in the denominator. And that is not okay. That is why we want to avoid that by getting rid of the radical in the denominator. Getting rid of this variable outside of this denominator, because we really don't know what this variable is. So let's go ahead and multiply, because we have this skill of multiplying. We will multiply by something that makes it possible for me to take the square root of. Remember, the index is a 2, so I want to take the square root of something with 6. That would be 6 times 6, right? 6 times 6 is 36. I'll be able to take that. And A, whatever A is, if I multiply by itself as well, I'll be able to take the square root of A squared, and I'll be able to get rid of that. If I multiply the denominator, we better multiply the numerator by the same exact thing. That means I'm just multiplying by a 1, which is okay. So we're multiplying this fraction times this fraction over here, so we can go ahead and take care of it. So let's go ahead and multiply the numerators first. 7 is an outside term times the invisible 1 here, which is 7. And 3 times a 6 is 9, and A is just times itself, right? So we took care of the numerator. Now let's take care of the denominator. We have a 4 times the invisible 1, which is a 4. And then inside we have 6 times 6, which is 36, and 8 times A, which is A squared. So look at how nice that is. I can go ahead and simplify it, and this is going to become 7. The square root of 9 is 3, so I can take that out. But then I got to keep the A inside. Okay? Then let's do the denominator. I can now take the 4 times the square root of 36 is 6, and the square root of A squared is A. So we just need to simplify a little bit more. 3 times 7, 21 times the square root of A, all over 4 times 6 is 24A. We can simplify it just to make sure that, if we possibly can, but don't you even think about simplifying the square root of A with A. You have something inside of the radical and something outside of the radical. They don't simplify it. Even though they are the same variable, you can't simplify it. It's the same thing as you telling me square root of 2 divided by 2, I can just cancel. That is completely incorrect. Okay, so this is a no-no. We cannot do that. 21 is 3 times 7. 24. There's really nothing we can simplify by. So we can simplify by 3. So this is divisible by 3, and this is also divisible by 3. So we can go ahead and get a 7 square root of A, and this is an 8A, okay? That is the simplest we can get this to be, because we're dividing by 3, and there we go, okay? So let's go ahead and try this other one over here with division. Let's see what we have here. We have cube root, okay? Because I have cube root, I'm looking for sets of 3, not sets of 2. Here, it was a square root. So cube root, I think of perfect cubes. I see 25. I'm definitely not going to multiply this by 25, okay? That it has to be the same index. I'm definitely not going to multiply by 25 because it's going to make a really big number. I'm looking for sets of 3. I see that this is 5 times 5. All I need is one more 5. And 5 times 5 times 5 would be 125. We can take the cube root of 125. It works. X squared is x times x. I just need one more x, and it would become x cubed. And we can take the cube root of x cubed. It works. So you're just looking for what you need to make a perfect cube. So since that works, I'm also going to do a numerator of cube root of 5x. This fraction is the fraction 1. The cube root of 5x over the cube root of 5x is just a 1. So we're really not changing much here. Now we can go ahead and multiply straight across. Numerator times numerator. 8 times invisible 1 is 8, and the cube root of 5x. And then on the denominator, we have 5 times 5 times 5, which is the cube root of 125, because we have 5 times 5 times 5. And x squared times x is x cubed. So there we go. Now I know I created this perfect cubes I can take the cube roots of. On the top is going to be 8 times the cube root of 5x all over the cube root of 25 is 5, and the cube root of x cubed is x. And there you go, it's simplified. We could simplify, if we could, the 5 with something here, but 8 and 5 are not, we can't simplify it. Again, don't you dare simplify the 5x with the radicand of 5x. That is very wrong. We are done simplifying it, okay? And that's good. Let's see if we have another division problem here to help you. Here we go. I have 2 more. Number 29. Okay, let me put a division place here. 29. I have a -3, which is okay to be in the denominator, but we have no idea what these x's and y's are. We need to get rid of it. We have a square root. Okay, there's an invisible number 2 here, so we need sets of 2. Okay, so let's see what we need here to make perfect squares. 12, there's really nothing I can multiply 12 by, maybe times 3. 12 times 3 is 36. So I can multiply times 3. 3 times 12 is 36. We can definitely take the square root of 36. Again, think of perfect squares. A 4, a 9, a 36, and so forth. You want to be able to create a perfect square. That's what we want to do. So 12 and 3 makes a 36. X to the 4th can already come out, so I really don't need anything for x to the 4th. But for the y, I just need one more y. So I would have y squared, and a 2 is divisible by a 2. Okay? I can take the square root of y squared. So there you go. This is literally all I need is multiply by a 3y. So I'm going to multiply also by the square root of 3y. And there we go. Let's go ahead and multiply the numerator times numerator and denominator times the denominator. We have a 2, and we have square root. 7 times 3, 3 times 7 is 21. X cubed, there's nothing other x to multiply. And y times y is y squared. So there's our numerator. We multiplied outside terms, which are coefficients times coefficients, and radicands times radicands. Let's go ahead and do the outside. We have, the denominator. We have this -3 outside, multiplying times the square root of 12 times 3 is 36. X to the 4th, and then we have a y times y, which is y squared. I know for sure that all of these are going to be able to be cleared out. We'll be able to take the square root, and we will not have a radical in the denominator. So let's go ahead and take care of the numerator first. We have 2 times, we cannot take the square root of 21. This x is also not enough for us to take the square root, but we can take the square root of y, which is just y squared. So we get 21x. All over, we have this -3 waiting. If you take the square root of 36, that would be a 6. The square root of x to the 4th, 4 divided by this invisible 2 is a 2. And the y, you have a 2 divided by this invisible 2 is a 1. So there we go. We cleared completely the denominator of a radical. Let's go ahead and simplify one more time. In the numerator, we have 2y times the square root of 21x all over -3 times 6 is -18 x squared and y. If you're wondering if we need any absolute values, we can look at the x first. Okay, let's take a look at the x, but let's go back to the original problem. We always go back to the original problem. Okay, the x here, it was an even. With the even exponent, we end up with the even exponent, so we don't need it. And the y, it was an even odd exponent, so we don't need it either. So we are safe. We don't need any absolute values. This is the final answer. All right. Then number 32, on your homework problem, it was not division, but I don't know why I wrote it down here. It's just a multiplication. It's helping us practice multiplication and division back and forth all the time. We have a square root and a square root, same index, so we can go ahead and multiply the inside. My technique that I usually use is I don't try to make things bigger. I try to make things smaller, even though I'm multiplying it. I would multiply a 20 times 10, but I don't want to make it bigger. I'm trying to make things simpler so I can take the square root. I see that 20 is 4 times 5, and a 10 is 2 times 5. I know you don't like to see this, but I like to write things out. Then I know that this 5's over here, I can definitely take the square root of them, okay? That's why I keep things factored out instead of multiplying it bigger. The x times the x cubed becomes x to the 4th, and then we have y to the 5th. So I know I can take the square root of this 5 times 5, which is 25, and the square root of 25 is just 5. I have a set of 2, they come out. I can take the square root of 4, which is a 2, so that has also come out, okay? So we can go ahead and do that. The only thing I could not take, so I got that one out. The only thing I could not take it out was the 2, so I'm going to put it back inside the 2. 4 divided by 2 is a 2. And the y to the 5th, you're going to have to break it out and write y to the 4th times y to the 1st power. The 4 can be divisible by 2, which will be y squared. But the 1, y to the 1st power, would have to stay inside. That's y. Okay? And then you just simplify it. 5 times 2 is 10. And we have an x squared and a y squared and the square root of 2y. Let's go back to the beginning, to the original problem, and check. Let's go ahead and check to see if we need the absolute value. Okay? So let's take a look at the x first, because that's the one here. The rule is even, even, odd. I didn't even end up with an odd, so I'm okay. And that's even, even, odd. I didn't even end up with an odd, so the y doesn't need it either. So that is okay. That is our final answer. So that is how I try to simplify it. A lot of people would probably multiply this. They would get 200. And, I mean, you know, why make things bigger, right? You're just trying to make things simpler. It's up to you how you want to do it. But that's what I keep doing here, keeping things factored out. So, and that is conclusion of our 5.2 multiplying and dividing radical expressions. Good luck.